Alright guys, so I wanted to record me doing some of these group practice and also individual problems. So if you were stuck, you could go ahead and watch these, and then if you are still confused, you're more than welcome to come in and I'm happy to help. Okay? So we are using the equations for potential energy and also kinetic energy in all of these problems in particular. So a roller coaster with a mass of 1,000 kilograms is at the top of a 370 meter hill under normal Earth gravity, 9.8 meters per second squared. Remember, that's acceleration. How much potential energy does the roller coaster have? Okay. Well, let's check our units. Okay. As you remember, we know that gravity has to be in meters per second squared. Okay, so we can check that one off. Our mass needs to be in kilograms, so we can check that off. And our height needs to be in meters, so we can check that one off. Now, our unknown is going to be the potential energy. However, we do know that the mass is 1,000 kilograms, that gravity is 9.8 meters per second squared, and that height is 370 meters, okay? The formula for this is right on the wall every day in class, and that is the potential energy is mass times gravity times height, okay? Now, all we have to do is multiply those variables. So we know that mass is 1,000, so we need to multiply that by the acceleration of gravity, which is 9.8, times 370, and we're going to get a big number. Now, what are the units we're looking for if we're looking for energy? Joules. So the final answer would then be 3,662,000 joules. I really need you to work on labeling those, okay? So for group problem 2, imagine the same roller coaster has also been built on the moon. Okay, so it's going to have a different gravity. If it still has a mass of 1,000 kilograms, that's the right unit. It's at the top of the hill of a 0.37 kilometer hill. If the potential energy of the coaster is 700 joules, what is the acceleration of gravity on the moon? Okay, so we know that the potential energy is 700,000 joules. We know that the mass is 1,000 kg. We don't know what gravity is, but we do know that the height is the same. Now, do you see how this says kilometers? We need this in meters. All we have to do with that is the hopping method, 0.37. All we're going to do is 1 hop, 2 hop. That'll bring us to 370 meters, just like in this first problem up here, okay? So, for the formula, same thing. Potential energy equals mass times gravity times height, but we don't know this gravitational force, okay? So for our work, what we have to do is you can either rearrange this equation or you can solve it algebraically, okay? So, I'm going to solve it algebraically. We know that the potential energy is 700,000 joules, okay? Just like right here. The mass is 1,000 kilograms. We don't know what gravity is, but we do know the height, which is 370, and then we'll just put gravity over here, okay? What do we have to do to get this to the other side? All we have to do is divide 1,000 times 370, just like up here. That'll cancel out. Over here, we're going to do the exact same thing, 1,000 times 370. What we're going to get is 1,891.89. Remember, I always want it to the hundredths, okay? Now, what is the unit for this going to be? 1,891.89. Remember, I said gravity is like the acceleration on Earth, okay? So that's going to be meters per second squared, all right? For this next one, back on Earth, the roller coaster reaches a final speed of 85.15 meters per second. So that's the velocity. At the bottom of the hill, it still has a mass of 1,000 kilograms, so that's the mass. How much kinetic energy? This is going to be a different equation this time. Let's check our units, though. Meters per second for velocity, absolutely, check. Mass in kilograms, check. So we don't know what the kinetic energy is. But we do know that the mass is 1,000 kilograms again. We also know that the velocity is 85.15 meters per second. Now the formula for kinetic energy is equal to 1/2 mass times velocity squared. When you're looking at this, don't square this entire thing. Just velocity needs squared. Okay, so if it helps you to draw those parentheses, do that. So for your work, all you have to do is 1/2 times 1,000 times 85.15 squared, and you are going to get 3,625,261.25 joules, because we're talking about energy. All right. On this back page, I'm going to go ahead and let you skip this one, so don't even bother doing that. However, you were supposed to do one on your own, okay? So for this one, a roller coaster with a mass of 500 kilograms, all right, good units, is at the top of a 200-meter, good units, hill under normal Earth's gravity, okay? So that's always going to be what Earth's gravity is if I say it's normal. How much potential energy does the roller coaster have? Well, we don't know what the potential energy is, but we do know that the mass is 500 kilograms. We know that gravity equals 9.8 meters per second squared, and we know that the height is 200 meters, just from reading that, okay? So the formula, again, is the potential energy is equal to mass times gravity times height. All we have to do is multiply those numbers, 500 times 9.8 times 200, and that gives us 980,000. What units are we going to have? Joules. Nice job. So, a baseball, though, has been thrown at 0.15 kilometers, good units, into the air under normal Earth gravity. If the baseball has 55 joules of potential energy, what is the mass? So we don't know what the mass is. We're going to have to solve for this in a different way. But we do know that the energy potential is 55 joules. We know that gravity is 9.8 meters per second squared. And we know that the height is 0.15 kilometers. We want this in meters. What do we have to do? We're going from kilo to just meters. So 0.15. We're going to hop 1, 2, 3, and we're going to get 150 meters. Okay? Remember, that's on that gold sheet. Formula then is the potential energy is equal to mass times gravity times height. And your work, all you have to do is 55 equals m times 9.8 times 150. And then all you have to do is 55 equals m, 1470. You're going to divide that on either side. It's going to cancel out, and you will get 0.037 kilograms.